factor out the GCF, I'm going to get a 2, then I have an x squared plus 3x plus 9. That's no longer factorable. That's not factorable. Over here, you've got a difference of cubes. So now you wind up with an x minus 3, x squared plus 3x plus 9. Well, isn't that convenient? I know, right? What do they have in common? Yeah, they've got that awful looking trinomial in common. So the common denominator for the numerator, it's weird to say, I don't know how to word here. What they share in common is the x squared plus 3x plus 9. What's left? What's left is the 2 and the x minus 3. Okay? Now you start going back and forth to what fraction has what. The fraction on the left has the 2 and the trinomial. It needs the x minus 3. The fraction on the right has the x minus 3 as well as the trinomial, so it needs the 2. So this gives me 3x minus 9 plus 2x. So my brand new denominator is going to be, excuse me, was it 5x? Oh, I'm looking at the wrong part. So it'll be 5x minus 9 all over 2 times x minus 3 times x squared 3x and a 9. Okay? Break it into smaller, more workable chunks, and your life becomes a little bit easier. Now that one flat out sucks because it's just awful. Okay? But now the denominator portion is the easy one. Because looking at the two fractions that are in the denominator, that first fraction on the left is a 3x minus 9. Well, what's the GCF of that? 3. So I factor out a 3, and I'm just going to do this right here because it's real quick. I get an x minus 3. So now what do those two fractions in the denominator have in common? They have the x minus 3 in common. And the only thing that's left is the 3. So now I know that the fraction on the left for the denominator, the 5x, has both parts. All I have to do is write down the 5x. The fraction on the right needs to be multiplied by, bless you, 3. So now this becomes 9. Starting to look rather clean, isn't it? Ish. So now you've got your complex fraction, the 5x minus 9 divided by the junk, all divided by 5x minus 9 divided by junk. So that bottom junk, the 5x minus 9 over something, I'm going to bring it up and flip it because we multiply by reciprocals. I'll rewrite that all down here. So we have 5x minus 9 over 2 x minus 3 x squared plus 3x plus 9 times 3 x minus 3 over 5x minus 9. Now, your favorite part of the day and mine? How does it go? No, if you're going to do it, you have to do it right. Nope, we're all going to stare at you until you do it right. Everybody stand up and stare at Hannah, please. I'm a real idiot, especially for 8th. That's great. So, what's your favorite thing to do now? What do you do? No, it's not. No. That's me. Yes, you're right. I am right. No, it's not. No, it's nah. Oops, wrong button. No, it's more fun. We're not picking on you. We're encouraging you. Ready? One now. No. It's no. Yeah, you're close. You're at the end. But you gotta put it in front of it. Yeah, right. How else do we teach student teachers how to harass people if their password doesn't work? It's nah. Think of ma, but a nah. Nah.
You can do this. I believe in you.
They're all starting to change. I got nothing else to do. You're close. Nah. This is what we do at this point. It's your turn to finish the
You
problem.
want this problem. Come on, Hannah, you're learning. You just need to get into the spirit of math.
I doubt it.
No, I was going to it.
You took one for the team. Nah. Oh, we need more than one. You know the song? It's like that, but faster. Oh yeah.
I got this.
You're so close. The enunciation is almost there. It's starting to become like.
Oh, the ambulance.
Oh, we get the ambulance back out for you. No, that's no fun. The ambulance is back. This is daily. But no, Nora, what will you do? You're just taller. Fine, since she's such a party pooper. How do you not feel like a good, like an accomplishment when something is done? Or you cross it off your list. Why not? All the cool kids do it. Whatever. I feel so like blasé about it now. It wasn't as fun. It's my 3/2 times something. Boring. Yeah. It's a good idea, but no. But people have done that. It's pretty funny. People have done that. It's pretty funny. You were saying, James, what was it, 35? You'll see people that because it's ingrained. I apologize. It's a -16. So, all right. First denominator. What times what 16 add together get 8? 4.
Oh wait,
You're
doing one on the left.
Yeah.
Okay.
We got 2x plus 1
X plus 4, X plus 4. The other one is the plus minus. So what do they have in common? They have one set of x plus 4s in common. I always recommend underlining it. Underlining. It's a little nasal. And now what's left? X minus 4 and x plus 4. Very good. Fraction on the left has 2x plus 4s. It needs an needs the x minus 4. So it has the 2x plus 1 times an x minus 4 minus 3 times this one needs an x plus 4. Now you gotta FOIL everything out, distribute, combine like terms. You get what? 2x squared minus 4x plus 1 is minus 3, 8x. So that'll be 7x minus 4 minus 3x minus 12. Excuse me. Negative 4, that is negative 16. Real quick. What can you do to the numerator? GCF. I'd always double check it, just in case sometimes you miss a term that could have been factored out earlier. Doesn't hurt. It really doesn't get me anywhere. There's reasons why we want to factor that stuff out or FOIL out our GCF stuff. That'll come in more handy when we go back to graphing. Like I was saying earlier, we do have a whole bunch of graphing to do with this stuff. And to do this work first is actually going to make the graphing portion of it easier. So, but yeah, it's easy. Honestly, graphing these polynomials, or excuse me, these rational expressions like this, are one of the easiest graphs you can do aside from like lines, because there's a specific way to do every one of them, and you by continually doing this process of factoring and finding zeros and doing all that, like what your zeros could possibly be, it's going to allow us to do the graphing real quick. So, the more I look at our notes, the more I look at how I wanted to make this work, flipping the graphing and the solving stuff, flip-flopping them, really makes a lot of sense. I'm going to do that from now on. And then we're good from there. Sorry you didn't have to do any of that. He doesn't carry student problems. What else we got? Sir. You have $1? Yeah, but it said 345, didn't it?
Yeah,
But it said 345 though. 345. Have you figured out what I mean by stuff yet?
wouldn't it be until 43 though?
It's a good one. So hopefully you did this one because it's gonna be graded for accuracy. That was a joke, Hannah. That was a joke. I know that you didn't like that. Do other teachers treat you like this? Oh, he does? Yeah, I saw him. Wow, you get a double whammy of awesomeness.
Yeah, and I get a view for next hour too, so I think
This is great. All right. In the numerator, I'm sorry, in that top portion, that's just a difference of squares. Okay. I'm sorry, squares. Difference in cubes. Sums of cubes. There's cube roots that are thrown in there. Now, my guess, without having done this problem right off the bat, is that working with that denominator might somehow wind up being simplifiable to that sum of cubes up top. So what I'm going to do is just factor this guy real quick and just write it down. You don't have to worry about any common denominators up top, but it doesn't hurt to have it there. So we'll have an x plus 4, x squared minus 4x plus 16, I believe. And that's just all over 1. Now down here we have some work. We have 5, we have x minus 4, x plus 4, 2, we have a 3x, and x plus 4. Now, can you see the reason why I wanted to factor up that cube now by having all those x plus 4s in that lowest denominator? That means that eventually, if we do this right, we should get some going on. I saw that smirk. All right. So now, between those two denominators, the 5 and the 2, these guys have in common the x plus 4. Those two parts. And then what's left? 3x and the x minus 4. Does it matter what order you put any of those in? Fraction on the left has an x minus 4 and an x plus 4. It needs 3x. Fraction on the right has the x plus 4 and the 3x. It needs the x minus 4. Don't forget here, remember yesterday we had talked about the most common mistake you guys make, distributing that negative into both parts. A lot of times that's where you guys will mess that up. So this becomes, what, 15x minus 2x plus 8. So we get 13x and then 8 all over this. So now we had that original numerator, the 1 over the sum of cubes. So I'm going to rewrite that part out. X plus 4, x squared minus 4x plus 16, I believe. And now I'm going to multiply by the reciprocal of the one we just did. X plus 4, x minus 4, 3x all over 13x and 8. Nolan, I know you're going to help me out with this. See, you're a good guy. Not like somebody sourpuss over there. Debbie Downer. Melancholy. Ready? Let's go. See how hard that was? No skin off his back. Do you feel better about yourself now? See? It's like every time the bell rings, an angel gets and then we got what, 3x, x minus 4, and a whole bunch of junk. Next year, she's going to walk by this classroom going, I hate you. But she won't say that out loud. She's too nice to say that. She'll walk by with a sign, or she might just walk by flipping me off. Yeah, you're right, she would. She probably just sign that says, the frowny face. What else? I'm so sorry. It's just perfect. You know that? It's just perfect. What else we got? Isn't this fun? Don't you guys just feel welcomed and loved in this room? It's
39.
30. Oh man. guys just don't like doing these complex ones, I'm guessing. This one you only have to worry about the lowest denominator, so one isn't so bad. Your common down here winds up being 4 and the x plus 1. Fraction on the left has the 4 it needs, the x plus 1. Fraction on the right needs the 4. So we get x plus 1 minus 28. So we get x minus 27 all over that. So now all we have to worry about is taking the 20 over the x plus 1. And then we're going to multiply by the reciprocal, which is 4 x plus 1 over x minus 27. I know you feel good about it, right? No, it's not like that. No.
Got it. I'm sorry, I just am still getting used to it. It's adapting.
And I appreciate that. It's the attempt that makes it worth it. And that's all I ask for is trial. Because if you make good mistakes, you learn.
I totally agree with you, Mr. Murphy.
I'm not passive aggressive at all. I'd wait a couple of years before you start really harassing people. Or don't. Yeah. Oh, here's a good question. This is a good one for this. What can't x be?
20.
Why? Good. Can you divide by 0? No. Now, you guys have all seen this before. When you have a graph, what happens when something doesn't exist? You know what it looks like on a graph?
It's like a big gap.
No. Think of this. If you have 1 over x plus 1, what can't x be? -1. Okay. So let's do this real quick. This is a good segue to mention where we're heading. This doesn't hurt any. So we know, you guys remember when you used to do graphs, you'd make a table of values? You guys vaguely remember that? Okay. So if I do a table set of values for x's and y's, if I put -2 in for x, what's -2 plus 1? -1. What's 1 divided by -1? -1, okay. We know that at -1, you get 0 in the denominator. What do you write when you divide by 0? Remember? Not undecided, you're close, it's undefined. This is undefined. Okay? What's 0 plus 1? 1. What's 1 divided by 1? 1. What's 1 plus 2? I'm sorry, 1 plus 1. I'm sorry, I'm getting ahead of myself. So this is 1/2, and this is 1/3. You okay with that? Now, if we were to graph this using this old school method of just plotting points, at -2, we said it was -1. At -1, it's undefined. When you have an undefined value on a graph, you put an asymptote. That means at -1, it never exists. You get what's called a vertical asymptote at that value. So at 0, we said it was 1. At 1, it was 1/2. At 2, it's 1/3. So we should probably get an idea of what's happening here. You can kind of see that it's curving. Kind of does something like, oh, sorry, I curved it too slow. It's kind of curving this way. And this one's going to be doing this. that's what rational functions are going to look like if we start the graph. As you factor them through, as you combine your like terms, as you find zeros in the denominator become asymptotes. So there's a whole reason why we've been factoring, the whole reason why we find zeros, the whole reason why we plot these things through this way is so that eventually as we go through all of this, this is where we head. Right? Just think, I thought it was a good one to show you what happens just by going through there. So it's good stuff. What else you got in those book ones? We're just gonna do some more of these today. I got some more already put on the calendar there. Yes, no, maybe so.
No.
What I did here, if you go to the calendar, there's two PDFs. One of them is the same PDF we did last night. The other one is this guy. It's the practice C. What I want to do is I want to do a couple more of these complex ones, but I want to throw in a couple of the other 3-bys. So let's do this number 9 together. And I'm just going to add, because these take a little bit of time. We're just going to add in 8, 10, 12, 13, 14. So we're just going to add those in for tonight. We'll look at this one together of what do you do when you have a larger, nastier looking, longer problem. And we're just going to add those what? 5? Let's add 5 more. We'll call it a day on combining. Because tomorrow it'll allow us to start solving. Take a big step forward. Hopefully what you guys are doing as you're writing this down, you're factoring it as you go. Remember, that's always a great little trick to add on to what you've been doing, because why write it twice? Yeah, we'll go back to it. I'll pull it back up again in a second. Well, let's just start with this guy. Excuse me. Let's see. That first fraction, you have x squared plus 4x plus 4. Last time I checked, that means what times what's 4? You add together to get 4, which would be 2 and 2. Good. The next one is an x squared minus 4. It's a difference of squares. So we have a plus 2, a minus 2. And the last one is just minus 2. So let's see. We have 2x. Why are you throwing these at me? I'm sorry. Oops. I mean, this makes no sense. Hey, Hannah, I was messing with you. Nora. Just a little. But no. All right. Between these 3 fractions, do they have anything in common? No. They do not. They don't have anything in common, do they? They don't have anything in common. All right. And this is fine. It's not the end of the world. Okay, we have all of our terms. We just put them all together. Okay. We have nothing in common. So we have x plus 2, x plus 2, x plus 2, x minus 2, x minus 2. For $1 million, what's the multiplicity of 0 of -2? You get it.
Oh, yeah. Oh, my gosh.
So does it go through -2, or does it, if this was just the polynomial, does it go through -2, or does it change direction? positive
Like $1 billion.
you know what? Sure. Here you go. Mr. Smart, in the top right-hand drawer there's a, underneath the pencil drawer thing, there's a bunch of erasers. Can you throw me like this? What? Throw me one? Yeah. Thank you.
Oh, damn.
Direction on the left.
I gotta cash this money. The banks will tell me.
Direction on the left has 2x plus 2s. It needs an x plus 2 and 2 of the x minus 2s. God, this is awful.
All of the $.
In order to have something in common, they all have to share one of the terms. They don't have the same terms. Think of it this way: if this was 2, 2, 2, 3, and a 4, well, that doesn't work out. Let me make it 5. They don't have anything in common. So your common denominator would have been 2 times 2 times 2 times 3 times 5. Same basic idea. Yes, sir. So this one already has. Oh, I got too many of them. Sorry, I was looking at the second one there. So this one has 2 of the plus 2s. It needs 1 plus 2 and 2 minus 2s. This is awesome. Move this over a little bit. The one in the middle needs a minus 2 and 2 of the plus 2s. And the last one, Anna, will you please keep going? Wow, that's awesome.
Oh my God. Please don't make
Here's the deal, though. As you get into these things, it's just a couple of distributive property problems. I know I say that, it's just a problem. But if you break it down into smaller chunks, all right? You guys do that chunk. You guys do that chunk. You guys do this chunk. And then we'll see what happens. And then I'll try and do some of it too and see if I'm right. 704. Did you guys get 2x to the 4th plus a 13x cubed plus a 30x squared plus a 28x plus an 8? I'm just guessing the first one, that's right. See the next one. So negative 6x squared plus 12x. Did you guys get negative 6x to the fourth minus 12x cubed plus 24x squared and a 48x? Yeah. So it's just like, what? It's okay. And then lastly, what did you guys get? Because I'm getting lazy. Let's. X to the fourth, 4x cubed. Yo. Is that better? All right, so yeah. All right, so we have a 2x to the fourth, 13x. This one? This one was. This one? Really?
Yeah. You messed up the first part.
Yeah, what the heck? It's 2x to the 4x minus 3x minus 10x squared plus 12x.
Wait, but the first one was.
X minus 2 times x plus 2.
Oh, yeah, Murphy's an idiot. You know what though? You aim at your own. No.
Yeah.
I think it's funny. All right. Anyway, so this problem just becomes ugly, kind of like some of the other things. Anyway, so let's do this then. 10, 12, 13, 14.
Just 10, 12, 13, 14.
You want to do 11 also?
No. No. No.
Actually, this one is pretty. This one's easier than that. Hannah, I want you to do number 11. And you know what? She's gonna walk out here and go, I don't know, is he serious? Or not serious? I don't.
So are we doing
10. 10, 12, 13, and 14. Hannah, also 11. I'm sorry, what's that? 10, 12, 13, 14. But Hannah is going to do 11.
as much as I want to accept $2 million,
Okay.
I'm just gonna throw it away and have another kid.
Thank you for homework. Not a problem. Hannah. You gotta show us some before you do 11. Thank you. Difference. Nah, I'm not gonna do that problem. It's like a sheep thing. I'll make sure to put it on the calendar for you, Hannah, so you can check it later. Be there.